Hello and good evening. Thank you for tuning in to this lovely webinar, Turning Unstructured Text into Knowledge Graph for ESG News using LLMs. I'm your host, Joaquin Malata, and I'm the founder of Swarm Community. And with me today is Prasad Yalamanchi, the CEO and founder of Lead Semantics. Prasad, it's always a pleasure to see you. I saw you this morning, but it's always a pleasure to see you. How are you doing?
Thank you, Joaquin. Thank you for having me here. It's my pleasure as well, and nice to be here. And hopefully, we'll have a good time for the next hour.
I'm already having a good time. And I know that the audience is in store for some interesting ideas, some interesting information. So, is there anything you'd like to tell us a little bit about your background? I think you studied, your academic background is in computational linguistics. And the last 20 years, you've been working in knowledge based systems. Do you want to expand on that a little bit?
Yeah. So I will start by correcting what you said about computational linguistics. My background is in plain computer science, but my enthusiastic adventure was into linguistics and knowledge-based systems quite a bit. And you were right that I have had multiple decades of experience in doing these knowledge-based systems and language-based solutions, information extraction to those kinds of stuff. Over the course of last 4 or 5 years, though, our interest has pretty markedly turned to machine learning, more importantly to language-based solutions, into knowledge and language solutions, which kind of has led us to create a product in that space. And you would go with the name of our company has something to do with semantics and knowledge and so on. So that's been where our time that was spent.
Okay. Well, if you're ready for it, I'm ready to dive right in.
Absolutely. Yeah, we have picked a pretty serious topic. Just going back to the slide,
Oh,
I would just want to start off with the title here. It's extracting knowledge from text. For ESG specific news or ESG specific knowledge from news. News, as it is in the textual format that we all are familiar with, and extracting knowledge out of it. And interestingly, using LLM, which is such a current and hot technique that folks are kind of raving about, talking about, or kind of can't have enough time with it. So that's how it becomes an interesting mix of things that we are going to talk about today.
well, I think it's a really, as you're saying, it's a really interesting combination of topics. Unstructured data, unstructured text is difficult to deal with on its own. Knowledge graphs is an up and coming topic. It's been in academia since the 70s and even before that in philosophy and other areas. And ESG, I mean, it's a relatively new hot topic. So combining all these things with LLMs, again, I'm ready to go if you're ready to go.
Absolutely. So I didn't stress on the knowledge graph part of it to begin with. I started out with knowledge, but we'll get into what this knowledge graph business is all about. Yeah.
Yeah.
So I will go on to the next slide. So what rightfully so the questions to start with are what are these knowledge graphs and what are these LLMs? LLMs, I mean, I will expand on the LLMs, large language models, everyone knows about it. That's the hot topic since probably about a year and a half or so ago. Such a young discipline, so to speak, but it has really taken the world by storm, and so all of that is pretty passe for everyone. But large language models are these you know um, machine learning language models. The dominant characteristic is that they are predicting the next word. They're generating the next word in a sequence of words that are input given as an input to these systems. The dominant characteristic, and so that kind of decides exactly how it actually behaves in various places where we deploy it and so on. So the main thing is that it has been trained on gobs of text, gobs of data, and then it has really captured all the patterns that it can. And so now it has access to all these patterns in the form of probabilities and so on. So when we input a sequence of words, so it is trying to see what is the most probabilistic, statistically significant next word to the a string of words that you have input. So combined with the new generated word, together is the highest probable, or one of the highest, depending on various parameters that we are allowed to set, like the temperature and so on. So it is like a predictive machine, and so people have called it stochastic parrots and all of that stuff. So the key is that it is able to generate something that is meaningful, appearing to be pretty, complete in itself, and contextual as well. But suffice it to say, whoever is receiving this generated output of these LLMs must be wary that they should accept it, they should validate it, all of that before it really becomes useful. Otherwise, you can be blindsided by some of this stuff that appears to be correct, but it may not be. So it has its own place in the way that it can really enhance someone's work. We'll get to that in terms of all the use cases that LLMs can enhance your outputs. Knowledge graphs, on the other side, are these mature technology. As you said, it's been around for a number of decades in the academia to begin with, but it is rooted in rigorous formal logic and all of that stuff. It's in set theory and things like that. um, but the essence of knowledge graphs is that it is a data structure that holds a connected network of proxies to real world concepts and entities. And so these entities are like nodes, and the edges are like the relations between these nodes. And these nodes and edges are proxies to real world concepts that you can relate to in the actual world. So that's what a knowledge graph at the bare essence is. And it is because it captures all the relationships between the concepts and such, it allows for instant instant communication of pieces of information that automatically are combined together and make sense to you as a human, because these are real world entities close to, right? And so they allow for easy understanding, they allow for higher level analytics. I mean, there are many good things, the applications of that are plenty. And of course there are some downsides to these things as well, so but we'll get to that in the next slide. Or do we have enough of a background on LLMs and knowledge graphs?
Yeah, I think you covered it. Knowledge graphs are a way to extrapolate knowledge in a graph data structure, and then large language models are a soup of words and ideas that are kind of weighed by a statistical model, and whenever you engage with it, it retrieves what is the most likely kind of response that you're expecting to see from a regular natural language exchange, a dialogue. I think we're good. Yeah.
Yeah. So I will. So so now, knowing that LLMs produce output in terms of language and so on. Of course, in the case of images, they produce images and so on. But we'll focus on the language and text side of it. And knowledge graphs are holding knowledge in terms of nodes and edges and things like that, uh, pertaining to a specific domain. So now, to set it in context in terms of how it is useful in a business situation, we need to know the text and knowledge. These are the two things that we are dealing with. And we are saying there is really, it is important to process text, it is important to extract knowledge and things like that. So it may be worthwhile to understand a little more deeply about what is this knowledge, and how is text relevant to knowledge. Just few moments spent on that. So I'll start with knowledge. Knowledge is this higher level abstraction than like a data and information. And of course, people have seen these pyramids that that talk about data, information, intelligence, and things like that. And knowledge is somewhere up there. So, but so knowledge necessarily is of higher value than information. In how so, right? That would be the question. And it has higher value than plain information in that it is actionable. So knowledge can be actionable, and action, any decision is an action, so it is a conscious thing that you're doing as a human. And so in order for you to make a decision, whatever that is relevant, I mean, in order for you to make that move, into taking that decision, you have all this knowledge that is, we'll call it, pieces of information that is complete for you to make that leap, to make that decision. And that is what is knowledge. You know, pieces of information are meaningful to you, but they are not complete yet. So knowledge is, it is one of those things that is complete for you to make an action. So that is, in that sense, knowledge is one step above, the data and information and all of that. So in order for something to be complete and characterized as knowledge, it has to fulfill some kind of a real world, need, or some kind of an obligation of sorts in terms of, taking you further into your actions. And so how is text, relevant to knowledge? Text is the other side of, it's like language. And language is meant to communicate, right? I mean, that is the purpose how language has come to be. And whatever it is communicating, it, it is actually communicating some information. And as we said, information are the, building blocks of knowledge. And so text holds all this information, pieces of information. And in a narrative text, because it makes sense to you as a human being when you're trying to read through language, if it is making sense to you, it means, it is actually holding pieces of information that is all consistently together to form pieces of knowledge. And so text is, and language, that's how, in fact, as a company, we have this tagline going. We say language and knowledge are two sides of the same coin. Wherever language is there is plenty of knowledge to be had. So however small it is, as long as it is communicating something meaningful, it means there is knowledge. And so that's how text and knowledge are kind of, very intricate. And language is the predominant way to communicate knowledge, is the de facto way to communicate knowledge. I mean, we have come to, build all these systems that extract these things from regular text and put it into a database. And then there are, series of applications that work with these databases to produce so-called knowledge systems later on. But if you had the technology like the way we have today, text is enough to produce the complete knowledge.
I mean, we've been
And as we,
communicating. Sorry, we've been communicating with symbols since the time of we since we were hunting mammoths. I mean, we were painting drawings on caves and things like that, and that's evolved into some sort of alphabet system, and that alphabet system has evolved into words. So words are the reservoirs of information, and information collectively makes knowledge, and knowledge can be transmitted in a message. That message can be encoded through verbal signals or text.
yeah, yeah, absolutely, absolutely. Yeah, and knowledge has this other side of it. Before you kind of tag it as knowledge, there is some level of a community acceptance that, we want to characterize this to be knowledge. And so that negotiated, mediated versions of, pieces of information is knowledge that way.
Uh, let's let's talk about knowledge and knowledge graphs in the context of a business use case. I mean, I'm sure that's what people are here for. They're more curious as to how can we commercialize LLMs and knowledge graphs to counteract the hallucination factor and bring accuracy and provenance and you know get the full value out of a natural language interface.
Yeah. So, I mean, rightfully so. This slide kind of, brings up the next thing about business use cases of LLMs and knowledge graphs. I'll start off with the use cases with knowledge graphs because it has been around for a long time. Um, and clearly, it is about holding knowledge in the most resident structure, I would say. I mean, like a network of nodes and, concepts and relations. And knowledge has this structure of a graph automatically. And so knowledge graphs are computational structures that hold knowledge in the most efficient format. And so that is knowledge graph. And there are the big applications with knowledge graphs in the last several decades have been like enterprise search, because necessarily knowledge is about domain. And so there is domain knowledge, and enterprises are, specific to domains and things like that. So enterprise search is, as opposed to some open-ended search, and Google has this open search, but at the end, I mean, it is like a big knowledge graph that is driving it. So So search and discovery is one big application, and domain specific applications, because knowledge graphs hold domain specific knowledge, and so domain specific applications, they tend to be reservoirs of expertise, be it in healthcare, be it in any finance. There is a lot of expert knowledge. People that have spent enough decades of time in that domain have accumulated all the best practices to all of those good things that come with having spent decades of time. That's all is a reservoir of expertise. So all of that can have a computational equivalence in a knowledge graph. And so domain specific applications are one side effect of that. And so that leads to business intelligence that is a lot more deeper. So it is a lot more valuable, much more richer, and all of that. And you get to and with these knowledge graphs you do integration across systems, being that knowledge graphs are designed with models that mimic the real world, and real world is real world to from multiple angles. And so integration of two different systems, be it if they were designed in two different circumstances by different teams and so on, as long as they were designed as knowledge graph systems or knowledge systems, the motivation for them relies on the real world, which unless we are hallucinating and delusional and things like that, there is a good chance that the integration is the best prospect in these knowledge systems. And integration is the biggest cost for the longest time in companies when they are like trying to merge and all of that stuff, even between departments within a company, right?
So
And yeah.
uh, I just want to look at this through the lens of search, discovery, and recommendation, because I think that is one of the most pressing reasons why people implement knowledge graphs to start. You mentioned the integrative component of it, and I think that is and infrastructure, so part of the infrastructure benefits. But I think that the benefit that people are looking for is, I want to be able to search for things. I want to look at things that are like that thing that I'm searching for, and I want to gain further business intelligence, whether it's about my customers, whether it's about sales, whether it's about any major component of my business. And we outlined here three major examples. I mean, we're going to dive deeper into ESG news, but when media, we have publishing, we have news like newspapers and magazines and things like that, books.
Or TV and all programming, yeah.
And finance, we have what private equity
Like,
firms, research.
absolutely, investment, research, I mean, all kinds of stuff in finance. Financial instruments have, in fact, one of the biggest knowledge graph systems is driven by ontologies, so-called. We'll get to that, within finance. And legal, has plenty of knowledge that kind of drives all the various things that happen in legal domain.
Case laws, contracts.
Absolutely, yeah. Yeah, and so as you said, search is pretty serious. That can be handled through knowledge graphs. And incidentally, and and hopefully in the next slide or the following slide, um, when we talk about LLMs, so LLMs have brought in pretty exciting dimension to how you deal with this, language, and all of what we just spoke, like in legal, in finance, and all of these things have plenty of text. In fact, if anything, they characterize these domains, right? And so chat GPT and these LLMs, they naturally have this understanding of narrative language. It is that I mean, at least they purport to understand, they project they understand, and who cares what is happening at the back end. We are not going to delve into whether they have conscious lives and all of that stuff. That's not our goal. Our goal is business use, and they seem to project they understand English or language, so to speak. I mean, of course, LLMs are working on all kinds of languages now.
I
They understand and they produce complete sentences and so on. Um, and they offer search, plenty search, pretty serious search as well. But they do have this issue of hallucination. You mentioned it early on. I would hate to say that is its weakness, but one way or another, if you put it into a business context where you are expecting a right word, for example, it's a pretty naive way to kind of whittle it down to a use case that we can understand.
Wait a
Of
minute.
course, it will.
Are you telling me I shouldn't ask ChatGPT if I should get heart surgery or if I should go to jail? I shouldn't place my faith in a machine yet?
Not yet, not yet. So ChatGPT are no machine at this point. But ChatGPT, so they do produce. If you are trying to write a fictional story, or even as long as you are there to mediate what it is producing, it gives you fantastic ability to reach and cover all of what you have not had a chance to read in your life. It is possible for the input that you have given, it has produced something you would not have imagined to produce yourself. And it could be a candidate, but unless you are alert and aware that it could produce something less than, you know, you know, correct, you could be blindsided. It could be a surprise. And that is what we are calling it as hallucination. But the other side, I would call it as, the creative, assistant. That's how you should see it.
Well, for one thing, it doesn't show its work, right? It doesn't tell you where it got the information from. It doesn't cite the sources. It doesn't tell you who wrote it, when it wrote it, what bias it has. It just
See,
kind of blends together this soup of words and serves it up to you and says, this is kind of what you were looking for, right?
right. Yeah, I mean, absolutely. All of that may be true, but I mean, again, we are looking at least what I'm trying to kind of, draw a line here is what is its use? What is its intended use? If we were to really put it into that kind of a use case, how best can we, use it with other systems that you may have at hand to produce some kind of a, bigger than, usual output, for example. The biggest positive, and which is what it is intended, its architecture is that it is creatively producing. I mean, you can call, there is no algorithm doesn't say, oh, I'm going to creatively produce something. All it is predicting something out of all the possibilities that it has seen, right? So it turns out to us, I mean, all of the experience that is manifested in the language out there in the world has been used to train these models, and it is in turn powering up your prediction of the next word for the sequence of input words that you have given. And then and that word that it has produced has now become the input, and so it produces the next one and next one and next one and so on, right? So that is the process, roughly.
So you're saying LLMs are not hallucinogenic, they're just creative. But
They are if you see, yeah.
what about the weaknesses of knowledge graphs? What what are
Yeah.
the limitations
So
of
the
those?
biggest thing about knowledge graphs from a business standpoint, again, I mean, because they are curated, there are human curated structures. So the deficiencies are directly reflection of the people that are building it, right? And it is material. The biggest drawback of a knowledge graph is that it's expensive. It's expensive because you would need, so-called the prior ontology, so to speak, the schema of, how we want to organize the domain specific information, knowledge. I mean, the same word to use. So you need proper skills like ontology skills, the engineering skills to put it all together. So that is a drawback. I mean, of course, when you compare with like a chat GPT and things like that from a user standpoint, to put something together is expensive. And then the lack of skills and all of that will also kind of make it a little bit difficult. And the domain expertise, that's the other thing, because the subject matter is uh, central to how you build knowledge, right? And so again, domain experts are not as many as typical IT professionals. So those are the dominant drawbacks there. So yeah, go ahead.
So you're telling me that we have LLMs being a creative and enthusiastic kid that just keeps spouting out nonsense? That sounds about right because it overheard what the adults were talking about, and then you have a slow but precise knowledge graph. How do they complement each other, child and grandparent?
Right. So before we get to this, there was one thing, where are LLMs really productively, helping the business, right? For example, if you take Microsoft's Copilot. So Copilot is, of course, behind that is like GPT-4 and, whatever, this generative AI. So this, interface is producing output in the context of a human. A person is kind of working with Word document, trying to write something, it is giving you suggestions. So the context is very well set, and there is a user that is the arbitrating, the outputs of generative AI. before they accept and move on. Much like in your Gmail and email, as it is giving you predictions and things like that, right? Same thing, you extrapolate that to Microsoft spreadsheet, to PowerPoint. I mean, that is now you're seeing everywhere. Wherever there is a human, if generative AI is producing something there, that is ideal, wonderful, because now it has the potential to keep a longer memory, and it's seeing what all you have done, and it knows all the possible different things, and it is probably picking something up which is more than likely the correct thing. And if in case goes wrong, you are there to correct it. And so rightfully so. And there is this disclaimer by all these companies that say finally you are the arbiter of what you accept. So that's where it is, and that's wonderful. So creatively, if you're trying to do some marketing, product, descriptions and things like that, if you're short of words and things like that, of course it's the best assistant that is there with you. And there are a lot of wrapper cases. You put wrappers around it for a specific domain and things like that. That's where most of real world applications are coming up right now. But now that we have covered the applications of knowledge graphs and LLMs, and both have weaknesses, as we said. If you see it as such, LLMs have this hallucination, so you cannot just strictly turn away and take its output and put it into some kind of a system that automatically processes it. You don't want to do that, not yet, right? And so with knowledge graphs, of course, there is a whole ramp up that is expensive and things like that, but it is something very dependable. It can be put into a workflow. It is domain specific and all of that. So is there a way to club these two things together? Can they really play together? And this is where the real exciting new proposition is. And in fact, I think knowledge graphs have been around, as you have mentioned, and we have touched upon early on, have been around for last 3-4 decades. Even in my career, last 2 decades and more, I have been hearing about knowledge systems and knowledge graphs in the last 10 years for sure. So they have been around, they have proved themselves, they're mature, but as I said, the weaknesses are pretty strong on a cost and those kinds of basis in a business situation. Now, LLMs are, they are completely, almost they produce outputs into different circumstances and things like that. Is there a way LLMs and knowledge graphs, if they put together, can they really add to each of their strengths and maybe cover up for the weaknesses? And that is the use case that is extremely exciting. For example, and this may be in the next slide, maybe, but knowledge graphs, see, you put together all this knowledge in the knowledge graph to do or service some applications or develop some applications. Search is one of those things that you mentioned, right? And plus, querying this knowledge graph to produce some kind of data that feeds into some sort of an application, things like that. LLMs are on the other side, they are like natural language interfaces. You input, you talk to them in natural language, they produce output in natural language. That is their resident, default way to interact. If you can club these two things together, knowledge graphs have this, up until now, interaction with knowledge graphs is pretty, very, esoteric. I mean, the query languages are kind of, like graph query languages, or, Sparkle, which is like another semantic query language, or APIs and, programmatic this and that. And so you really require some kind of a depth in IT and so on to deal with these things. If you can overlay, and if you can see a way to overlay large language models on top of knowledge graphs to interact with what is there in knowledge graphs, for example, with the natural language interface through LLMs, and if LLMs can one way or another mediate that communication back to these knowledge graphs and produce the output in natural language, that is fantastic. Now we have democratized interaction with knowledge graphs. And that is exactly one of the serious use case that is already proven and it is working out. The other exciting thing, yeah, go ahead.
No, I just want to add, it's interesting that you say that LLMs working as an interface rather than as the main means of searching through information.
Right. As we said, if it were to only be part like a chat GPT, so you would have to mediate on that. You're not dealing with the domain that is knowledge that is there in the knowledge graph, right? Of course, you could use LLMs for its own, all the breadth of knowledge that it has, as long as you are kind of, correcting what it is and accepting what it is producing. And of course, that has plenty of use cases by itself. But now making use of this big behemoth of a knowledge graph in a big enterprise, for example, you don't have to write complicated application that uses this esoteric query language to go at this knowledge graph. You can use LLMs. Of course, you have to kind of string it up to do that. That's a pretty significant use case. On the back end, of course, it would have to translate that into the language that knowledge graphs understand. Yeah. The other thing is that knowledge graph, as we said, one of the weaknesses of knowledge graph itself is that it takes up quite a bit of effort to build it up, because it is domain specific. Subject expertise has to drive the schemas and how you organize these entities and interrelationships and so on. So all of that is like a pretty involved affair, so to speak. Now, could LLMs help you there? And that is what is the other exciting use case. So on both sides, we said in so many ways that knowledge graphs are an exciting, artifact, data structure, because it is holding domain specific knowledge, and knowledge is very high level abstraction that is closer to stakeholders and users and applications and so on. There is very less room for misinterpretation because it is driven by real world concerns and so on. So it is a something to attain, in all of these transformations of information and so on. So if LLMs can produce that one way or another, and LLMs can help you query these knowledge graphs, you have really seamlessly connected raw data that may be available through all kinds of channels into a knowledge structure, and be able to query it for your application and downstream uses. So that is the vision of how you can really club these two things together.
You know,
In many ways, some of these things are already operational. Yeah.
at the end of the day, everybody says you have to be a data driven decision making organization. But do you need to be data driven, or do you need to be information driven, or do you need to be knowledge driven? Because knowledge is the information that has context relative to the actions that you need to take. So,
Right.
knowledge
Yeah.
graph support knowledge based
Knowledge
decision.
graph is the most valuable artifact that you can aspire to, with all the data that you might collect it. Whichever the workflows that you would have to, corral it through, one way or another, if it ends up becoming a knowledge graph or ends up in a knowledge structure, I mean, forget whatever we call it. If it manifests as knowledge, which means, people are able to relate to it in the context that they interact with it, and all kinds of good things happen. So there is you don't have to be in a world of miscomprehension in business situations and so on. With knowledge in the middle, that mediates all kinds of decision making.
So now let me ask you this. Why are we talking about ESG news? Why do we care about the environment, social and governance, and the news in that context?
Right. So I have picked ESG as just as an area to focus, to kind of talk about how LLMs and knowledge graphs kind of work in this space. But any other place, I mean, in any domain, all of life is fully made up of different domains as we kind of cut it into. But otherwise, it's any domain is game actually. And ESG is current, and it has a lot of text, and we have been dealing with a lot of that text also in our own experience. And so I thought that may be worthwhile topic to bring up.
Okay, and ESG is involved with regulatory compliance and green investments and just a rich interconnected network of public and private partnerships, current events. So that leads me to ask you, okay, what is controlled data and what is alternate data in the context of ESG news?
Right. Just one step back, ESG is pretty prominent over the last decade or so for all these obvious reasons of climate change and things like that. But from the business standpoint, these climate events that are happening, like big hurricanes and things like that, who knows how what it is, but in one way or another, there is enough of a correlation between these events to the financial debacle also. Enough of it that businesses have taken interest, and one way or another there's a lot of public interest as well. And so it's only natural that folks want to track them and so on. So if you just look at it from an investment and finance standpoint, there is a huge interest, at least till last year we have seen that. There may be ups and downs here and there, but in general, that is the trend. A lot of investment houses and ETFs, so-called funds and so on, they take funds and they deploy them in these target companies that have some kind of climate goals that they are targeting. So that is the general environment that we are looking at. And so in that context, when you want to, or a fund is interested in investing in some company with a goal to deploy it in a manner that kind of either reduces use of fossil fuels or things like that, some kind of a climate goal, they want to evaluate. And the only access to data that gives them that possibility of evaluation is two kinds. One is the data published by the company itself, so for all the requirements for regulatory compliances and things like that, through those submissions to SEC and things like that, if it's a public company, um, that information is disclosed by the company itself, and so it is very controlled by the company itself. That is the word, from that angle. So as an outsider, if I'm a fund and I'm trying to look at and evaluate this company, I'm only having to go by what they are claiming and what they are disclosing. There is no third party oversight and things like that. Of course, regulations have come in and there is all of that, but there is so-called a term called greenwashing, where the company itself is kind of saying they are reducing carbon emissions by so much and this and that, whereas there is no real way to evaluate and come to a proper conclusion on it. And so the alternate way, and so hence the alternate data. This is the outside in view about the companies, right? Outside in view, which is like news, for example. The companies don't control what gets published in the news, right? It is like a media house that is publishing this news, and maybe it is talking about a company in question, maybe their manufacturing plant, maybe their supply chains, maybe there is some disruption that is happening in this world. So all of this outside in view, objective likely, right? And so all these other sources like social media, so these are all alternate data.
So there are all these channels of information, all these channels of knowledge, reporting from New York Times or the broadcasting from a CNN or whatever legitimate news source channels we have. So there's all these sources of information, even so social media, right? Peer-to-peer reporting of events happening live. How do we extract facts from the news? I mean, I think that's why we're all here, to
Yeah,
really get an understanding of how we do this for
right.
our benefit.
Yeah,
We
yeah.
don't want an
So
ontologist modeling an event today and have it be done by the end of the month. It's not fresh, right?
right. So, I mean, for example, ESG news is what we were talking about, right? So let's say, ESG, there is news that is going on. There are ESG publications as well. And so even journal like Wall Street Journal to, any other business and finance news bulletins, they hold information related to ESG, for example. And when we say ESG specific facts, you have to know what vocabulary constitutes ESG related terminologies, right? So there is an ESG, if that is the domain that you are interested in, there is ESG specific vocabulary and then the terminology. And there is some level of a formalization of these terms, because these are the terms and words that get mentioned in the news. And so if you were to pick up facts about ESG, you better go about it looking for these words in the text as well, right?
Mm-hmm.
And so it is
Keywords.
not only, yeah, I'm sorry, yeah,
No, I just said keywords. Keywords.
right, absolutely, yeah, so words that are related to that domain, right? So of course there is a formal way to organize all of these, that is like taxonomy and so on, right? Before we get to that, these are like vocabularies and terms of the domain. And it's not only just terms and concepts and so on, it's interrelationships between them as well, right? And so that is what is getting communicated in this narrative news. The discourse of an article kind of lends itself to giving you that knowledge of various concepts, like carbon emissions being reduced by certain amount by this organization, and all of that may not be said in one sentence, but somewhere sprinkled in the entire article is this company A is actually spending their effort through their facility here, and all of that stuff. It gets sprinkled over a span of an entire article, for example, however long it is. But you would have to piece it all together to get that bit of knowledge.
So, okay, there's actors, which are natural actors like people, and there's legal actors or legal entities like corporations or LLCs or whatever kind of company. There's events, right? Something happens today for
Yeah,
an actor, so that's a action. Well, an action is taken from an event as well, right? An
yeah,
entity can take an action on an event, or an event can produce an action on an entity. So those are facts, things that can be verified by third-party sources, as you said in the previous slide, right?
right. So, I mean, the text is now your truth. That is the basis for where you go back to and verify what you have picked up, whether it is right or wrong. You may have picked up some word which probably, through all these sophisticated systems that we put overlay on top of our solutions, one way or another, there is machine learning pieces as well in how we interpret what we extract from these running texts. And so maybe certain prediction has, maybe threshold for your classification is at a different level, and maybe it has predicted it wrong. And so where do you go back to verify whether it is right or wrong is the text. Because as a human, you are there to kind of verify it is there and it is complete, and it is, it communicates everything that you want to finally kind of backstop all of what your extractions have been, right? And so the text is now the ground, where is the fertile ground for producing your knowledge. And as narrative and as spread out, it could be across documents. For single pieces of knowledge, sometimes one part of it may be complete and consistent, but it's only a part of higher level knowledge that you're looking for, and so it is spread across multiple documents and so on. So the knowledge graphs have a potential to kind of put it all together and make it meaningful at the level of what makes sense from a domain point of view.
What is the role of ontologies and taxonomies in all this mix? I mean, you made
Oh,
hint of that earlier on, but in the context of knowledge graphs, why are they relevant?
yeah. So we just touched upon taxonomies. I mean, it's just an extension of vocabularies and terminologies, and taxonomies are formalizing, hierarchy of terms. Like, for example, you have a car, there are 5 different varieties of cars. I mean, so they all, so you can organize this, the so-called one single conceptual thing, but it manifests as multiple individual entities in the real world. And, and they typically form hierarchies, so that's a taxonomy. And so all these words, or whatever the labels you associate with these things, appear in the actual running text. And so you would have to one way or other make sense of these things and put it in the right, concept. I mean, so no matter how many different ways of these cars and models that appear in the text, they are all automobile or a car, right? So that's what taxonomies kind of, help you get there. Whereas ontologies is the next level concept that uses taxonomies, but it imposes this other real world constraint of interrelationships between these concepts. So there is, any real world. We kept on talking about knowledge graphs being, you know, connected nodes and entities and all of that with a real world, extension, so to speak. They are extension of the real world. So real world is like, different things, different entities, different objects, and there are relationships between these things, and that is what ontologies bring in. And it's not one to one. There are hierarchies of relationships and things like that. And ontologies is that science of modeling a domain.
So taxonomies would be used to decompose and sort of break out into categories, right? Like you have ESG news, and then you have environment, social, and governance, and then there's subcategories of each area.
Yeah.
And ontologies is more looking at the relationships between different entities, you know.
And yes, you mentioned those categories end up becoming like, some hard class, so-called classes. So these are like type systems, so to speak. And so you will associate a car as a class, and then or an automobile. And so you kind of, have these relationships that are very formal. So when I say formal, I don't want to get into that, total science behind this too much. but it is very rigorous in the sense that much like how humans will understand these interrelationships, the software, the machines will understand once it is modeled in an ontology. And so what that in another way, what it is telling us is that it is able to really make sense. If something is missing, for example, it can reason out and produce that.
I think we're getting close on time here, but
Yeah.
you know, why do I want to use this computational mumbo jumbo? Why don't I just read 10,000 newspapers and tell you what I read from them in a report when I get to it?
Yeah. So for one thing, I mean, 10,000 newspapers you could not humanly read and make practical sense in a practical time frame. So you would need some level of automation support, automated way to kind of get at it. Provided there is important knowledge to be gained from these 10,000 articles, right? And so, for example, as you rightly put in this slide here, on the right hand side, that article is an article from a pretty reputable technology magazine. It's, I think, MIT Review, um, and it is talking about solid state batteries being invented by a company, and these solid state batteries are replacing liquid batteries in electric vehicles. With this invention, and liquid batteries have some downside to it. For example, one is that there are safety hazards associated with liquids, more than like solids. And then, of course, range is another important constraint. And so the solid state batteries of the new invention is solving these two aspects. And so this is what is being discussed in this article in a very reputable magazine, in a narrative language article. And another interesting thing is that Volkswagen has already picked up on the invention, and they have already announced that they will put it into production sometime few years after they have this article has come out. Now, if some analyst has read this document, they have all the information they need to make a decision on, if be it due diligence on the company, be it at least it's a complete whole knowledge piece of knowledge that someone can attach some decisions to it. Whereas if you want to automate this process, you without these language technologies and these knowledge graphs and LLMs and things like that that are handy and available now, it would have to go through normal routine information extraction processes, and then they end up in some relational database of some sort. And so there is a huge time lag, and then it is between multiple people, and so there is lack of fidelity in the final output that comes up. And then there is a lack of there is a disconnection between the original source and the final information the analyst gets after like few weeks. Whereas if these documents were to get processed through some kind of a sophisticated pipeline we are talking about, and automatically all these, highlighted in different color, those entities and so-called relationships, the entire knowledge is in place in terms of a graph structure that can get into a knowledge graph. And, if you are able to query it through natural language and get an answer saying that this quantum space escape is the company to invest in because, they have come up with an excellent invention in this time, and some major companies, actually putting their weight behind it. Such is the prospect. If you directly go to the source, where the source knowledge oftentimes is coming in language. And that is the prospect that you're talking about when you merge knowledge graphs and, large language models.
So I'll be able to grab that 10,000 stack of newspapers, look through each newspaper programmatically, and siphon out every chunk, every passage that makes a mention of solid state batteries and any entities that are tied to that.
You can string up a query through, again, mediated through a large language model. And of course, you will string up some prompts in the middle that will actually, you know, dissolve that, or one way or another map it back to the ontology of the knowledge graph that you have at the back end,
How's this
right?
different from GPT? I mean, it's just going to give me another smoothie of words.
Because it is considered, because it is now guided by what is found in the knowledge graph, which we said is curated, right?
Okay.
And so, when we look for these organizations and, interrelationships between these organizations, or, money and whatever the different concepts, it's all rooted in the knowledge graph. And so you are kind of reducing the scope, and it vastly reduced. And of course, now these large language models, given highly constrained situation, they produce reasonable answers that you can depend on.
Will I be able to retrieve the exact newspapers that make reference to the solid states so I could do further research
Absolutely.
if I need to?
Absolutely. Not only does it bring you the actual paragraphs and things like that, it'll actually get you all these highlighted elements like 2022 as the time, or 2025, the amounts, and all of those things as well, with the mix of other language models. So you can combine all the facilities that we have garnered expertise so far, put it all together in this final wrap up to produce the final answer as an analyst, for you to kind of make a decision and be confident that this decision is rooted in some underlying raw truth, which oftentimes is coming from text. Yeah.
So let's open up the room for discussion. I mean, I was eagerly awaiting for somebody to poke holes or ask questions, but we're open for business. So if you have any questions around the material we've covered so far, we invite a healthy discourse. Feel free to comment, and we'll get right on your questions. Um, but Prasad, in the meantime, do you want to just illustrate a little bit on what's going on in this slide here?
Yeah. So this slide is pretty much talking about that intermediate system that uses LLMs and semantic technology, which is the technology behind knowledge graphs. Right? When you club them together, you can feed in narrative text, long form text like textbooks and so on, to all the way the shortest things like tweets and things like that. You can feed all of them and extract meaningful information pertaining. When we say meaningful and knowledge, I mean it is pertaining to a domain or a knowledge specific. So there is an ontology driver at the back end, and so what gets extracted automatically converts into a knowledge graph, a fact graph, so to speak, driven by an ontology. It can easily be, through multiple steps, can be integrated or populate an enterprise knowledge graph, which is like a holy grail in an enterprise, as we said earlier on.
Now you said text might be one place, but what if I want to do like a like a website that has de facto standards? Like what if I want to go look at a source of factual knowledge? I mean, it could be a website, like maybe federal guidelines on how to build a thing, or ISO standards for this thing, so long as I have the license for it, right? I mean, I'm not
Yeah.
advocating for stealing IP, but if it's publicly available or if you have a license to consume it, can I turn that into a knowledge graph?
As long as you have the license for it, absolutely. I mean, there's a lot of public sources actually, and knowledge graph technology has been around so much, and majority of the times it was Department of Defense and the government, departments have used it for publishing their data using the standard so-called RDF, and so on. And so those kind of resources are available in plenty. There are many ontologies for different domains that are public in the public space, as well as as you rightly said, standards and things like that that are there. You can, if it is accessible and you have the license for it, I mean that is a nice fodder for these kinds of systems to turn them into knowledge graphs, so you can build different applications that are much more rigorous and dependable.
There's something that's bugging me here that we didn't cover, I think, closely enough. Okay, so it seems all fine and dandy, and I'm in daydream mode right now that I can take any text and create a knowledge graph. But we did discuss that there's a heavy investment of data modeling and ontology building.
Mhm.
So how does that work? Because it's not going to come from the air,
Okay.
right?
Right, absolutely. So that is one of those things. In the past, creating an ontology and all of that would have taken literally a real expert sitting there doing all of that. Even now, you need an expert to validate what you produce, but there are automated mechanisms. For example, as I said, ontology itself is knowledge, and it is, you can build that knowledge based on sample documents of a domain. The ontology is made up of the concepts that are there in that domain. If they are reflected in the documents, let's say sample documents, all that concepts that are actually going to be part of your ontology will be discussed in the documents. And so you are able to pick those things up. Of course, there are various techniques, and you won't get the final, highly, curated ontology on the first go, but you would get all the concepts, all the relationships that are possible between these concepts. And then, of course, now the time to get your first good version of ontology has drastically reduced to kind of, what used to be, let's say, 100%. Now it would end up being, less than 20-30%. At least all the concepts that are meaningful to you are rooted in the sample documents you fed into this, same pipeline that you're looking at.
Truth be told, this kind of mirrors what it is to work in real life when you're working with knowledge. I mean, I've walked into consulting assignments where I look at a database schema, or I'm looking at a completely new domain. My obligations are to do research, to learn the vocabulary of the industry of the domain, and then
Mhm.
learn how that applies to the schema, and learn about the business life cycle of how value is converted throughout the organization. So you're saying that this is a programmatic way of approaching this. Either way, whether you're doing it through organic intelligence, so you have to shove information in your head, or you have to shove it in the computer, you need to validate it with humans, with experts, right?
Right. Yeah, it's absolutely, so because the knowledge that once you finally say, okay, this is the knowledge, this is the structure of the knowledge that I accept for my system, somebody has to validate it, because you are going to put it into a workflow, automated workflow. And that is one other use case that just GPT alone will not get you there, because it always requires a human in the middle at this time. There have been all kinds of systems that are on the flow, like chaining different prompts and things like that, but without somebody validating the final outcome, you can't directly feed it into the next software automatically. And so you will only be, just multiplying the probabilistic, mismatches along the way. Whereas if there is an ontology driven, because ontology itself has taken all that effort of being curated and so on. And so if ontology will be playing the role of a human, and so it has a potential to automatically put together workflows using LLMs to kind of, fill different pieces of, work along the way, which is exactly how, building knowledge graphs makes a lot more, becomes easier with LLMs.
All right. Well, isn't it cheaper to hire somebody like me, a consultant, to walk in, do the work, and walk out?
It will be, so the net output is highly valuable anyway, right? And so if you are able to handle this kind of pipelines and things like that, of course, you're doing it much faster, but the value that you're generating is, you're not, in no way you're discounting the value. The value produced is value produced with knowledge,
So you're
because
producing a knowledge asset that can be reused and extended.
yes, absolutely. And, that is, knowledge is like, it has its own, unless the business use cases move elsewhere, right? I mean, of course, hopefully the knowledge that you're producing is relevant for the business and a particular business use case. And in this case, you are doing it much faster and cheaper and so on. Yeah.
Okay. Well, we're drawing close to the end of the hour, and I would invite anybody that is watching this or rewatching it or rewatching it, if they have any questions, leave them in the event, and we'll come back to it. Prasad and I will try to answer whatever questions you have. But I'll end the conversation with who should reach out to you, what should they reach out to you for, and yeah, and anything around that you want to just address.
Yeah, I mean, so we have talked about these knowledge systems and LLMs and coming together to solve a unique problem of creating knowledge graphs in the first place a lot more easily, and then being able to query a knowledge graph a lot more easily. And it is, when I say a lot more easily, it's a step up from even the latest techniques like, RAG techniques on along with LLM, like retrieval augmented generation. Knowledge graph creation itself uses RAG, but then knowledge graph being used as a search mediator, gives you these pretty dependable final search results. And in that sense, it's a step up to anything that's out there. But we are literally using what has been around in a mature fashion for all along. And so, anybody that is curious to explore these things with us, they can certainly reach out to us at the email address that is given, and my LinkedIn profile is here. Reach out to Joaquin as well. Um, so thank you for joining us for this interesting conversation.
Yeah, thank you everybody for joining us. And again, if you have any questions, comments, concerns, we're happy to have a public discussion, or if you'd like to have a private discussion, as Prasad mentioned earlier, feel free to reach out. We're more than happy to talk. So have a good night.
Good night. Thank you.